Good evening, Dr. Sonal.
Yeah, good evening, sir.
It's nice that I got in communication with you very recently, especially knowing your vast experience and your research on biochar, especially from Terry you have done, and you have very intense knowledge. Maybe I was thinking this particular conversation between us would also help others to understand, especially the biochar characterization, because many people they misunderstand what is biochar and is it biochar. Even by holding it in their hand, they are unable to say what to call. Because the testing protocols are very challenging, I mean to say costly, and we don't have that many centers also available everywhere. And there are so many parameters that need to be tested. So this is one of the biggest challenge that we have currently. So in this context, I would like to ask a few things. See, right from pyrolysis stage,
Right.
pyrolysis is very fundamental in biochar process. Say any organic mass, if you take on an average, say it has around 45% carbon, then around 45% oxygen by weight I'm telling.
Yeah.
And there is some percentage of hydrogen, nitrogen, and many other minerals in it. So this way, an organic any biomass that it has. But finally, biochar means here we are looking, say, up to 85% plus carbon, fixed carbon, or even up to 90 plus percent fixed carbon. That is
True.
the high standard biochar, let us say. So this way, ultimately, all these elements which were existing in these hydrocarbons, that's the basic structure. So they have moved on in the pyrolysis process. So you can elaborate a little bit exactly what happens, how they get detached. So otherwise, they are very much related in any organic matter. How do they get detached? So you can add on something to this.
Sure. So, first of all, thank you so much, Dr. Sai, for giving such a nice introduction. And it's my pleasure also to be connected with you. And it is like it is really important nowadays to have a knowledge on this biochar that will help us to sequester carbon to increase soil fertility and it will be a win-win situation for the farmers and for the environmentalists if they are working in this direction. And in India, it is starting now. So it is very important to understand how it is prepared, what is pyrolysis, and what are the different how it is basically the different fragments are getting detached, and what is biochar and what is biomass. As you correctly said, biomass is 45% carbon or something around that, and similarly, it is 45% of oxygen, and then it is hydrogen, nitrogen, sulfur, and minerals. They all make up the part of a biomass. Now, what happens is there are different processes like torrefication. We have heard of pyrolysis. So it is all temperature dependent. If we are going to say up to 200 degrees centigrade, if we are heating in absence of oxygen at a lower temperatures up to 250 degrees centigrade, then it is known as torrefication. Whereas if we are moving ahead, if we are increasing the temperature and the temperature is going to 450, 500, 600, then it is getting converted or the process is known as pyrolysis. So the products obtained are also different. As a biomass is made up of, we know that it is made up of, say, cellulose, hemicellulose, and lignin. So these all cellulose, hemicellulose, and lignin, they are made up of carbon, hydrogen, oxygen, nitrogen. These components. So if we see their breaking pattern, then at lower temperatures, first of all, hemicellulose is removed from the biomass. So hemicellulose breaks down up to say 250, up to 200 to 250 is the range where the hemicellulose components they break off and they starts forming in the form of gas. So any plant body that is rich in hemicellulose will form more of gaseous products at a temperature of up to 250 degrees centigrade. Now what
Is
happens
it
when
something like volatile matter? Is it what we call in this thing? Sometimes
Basically, first of all, we will talk about the moisture. The plant body is consisting of moisture also. So whenever a biomass is heated, so up to 100 degrees centigrade, 105 degrees centigrade, all the moisture goes away. So moisture is going away in the form of again vapors. Now, when we are increasing temperature from 100 to say 250 or something, then definitely gaseous forms are coming, volatiles. What we call it volatiles are of two type. One is you can say you can say the one that we can condense and the non condensable part. So condensable part of the volatiles, they are formed at a higher temperatures that we can condense and we can get oil out of it, which we call it as bio oil. So at a lower temperature, these hemicellulosic components, they result in the non-condensable fractions only. That is mainly in the form of CO2, CO, in the form of H2, in the form of nitrogen. These molecules, they form non-condensable gases majorly. Yes, there may be some volatile if present, that can be condensed, we can say, but majority of the condensable part is obtained at a higher temperature in which lignin and the cellulosic components starts degrading. So up to 250 degrees centigrade, 250, 280 degrees centigrade, we say it is a hemicellulose that degrades. After that, up to 350 degrees centigrade, we say 300 350 that the cellulose is completely degraded, and this lignin is the third part, that is basically phenolic components. The if you see lignin, what is lignin? The hardest part of any biomass, if we call it as a bark is very hard, whereas if we consider a leafy structure, then they are very soft. So husk or leaves, they all constitutes the three materials: hemicellulose, cellulose, and the lignin. Percentage varies. If we call it a bark, then it is very hard, so the lignin component is high. If we take leaf, then leaf is rich in hemicellulose. So when you will pyrolyze leafy biomass, then you will get more of gaseous as a product. Whereas if you will pyrolyze lignin rich plant material like barks or woods or woody material, then more of volatile, that is known as condensable volatiles, you will get out of it.
you mean to
So,
say the wood vinegar kind of material we get more from the bark like material? Is it so like
yeah, so
yeah,
there are
content
also,
is extracted traditionally from the bark of the wood. So
yeah,
similarly, the wood vinegar is one of the products from the bark because
yeah.
maybe the plant wanted to protect itself, so it has lots of such oils in its bark because it's a kind of insecti repellent and insecticide also.
Yeah,
Yeah.
true, very true, very true. So this wood vinegar, again, when we pyrolyze at a higher temperatures, then also the plant body, it breaks in different manner. So acids are also formed, then aldehydes, ketones, then different organic compounds are formed. There are different chain lengths of hydrocarbons are also formed. So wood vinegar is more of acidic components that are formed, and along with this, we have some thick viscous oil also that we call it as bio oil, that is having almost 100 to 150 fragments in it, and they form the volatile condensable fractions that we can condense during the process, or if we are not condensing, then we can make them burn in the process itself to make it as a circular or a self-sustained heating process. Within the system also we can burn these volatile fragments to derive heat out of it. If our focus is not the oil, if our focus is not to collect oil as one of the byproduct, then we can use these vapors that are rich in oil fragments, that are oily fragments, I can say. Then we
Is
can
it
burn this.
suggested to combust them or to extract them and use it for some other purpose? Which is more economical in this current scenario that many are involved in biochar production?
It again depends on application. If our focus is to utilize this oil as a value added product, or to convert it into any particular product, to make it chemicals out of it, or to convert it into any other specialty chemical, then it is always good to trap them and to utilize it as a value added chemical, because these products have higher value. Whereas if we do not have any focus on collecting this oil and converting it into another byproduct, then we can burn this within the system so that it will not pollute the environment, so that we can recover heat out of it, and at least our system will be self-sustainable as far as heat
So,
is concerned.
so it is improving the efficiency of the reactor, pyrolysis.
Yeah. If we are burning the vapors within the reactor, then definitely initially heating will be required. Then after some time, it will be self-sustained heating.
Yeah. Okay. So here I think this proximate analysis is one of the things within which all these four things are tested. Another thing is ash content. So what
Right.
is ash actually? When carbon is there, it is also can be combusted. Carbon can be combusted. I mean to say the biochar can be combusted. So
Right.
ultimately the carbon also moves out. So whatever is left is white color ash. So it has all the minerals.
Yeah.
And what else?
So what happens is the process, if we are talking about combustion, then the products are different. If we are talking about pyrolysis, then the products are different. If we are talking about combustion, combustion takes place in presence of oxygen. 100% oxygen is there. And in excess of oxygen, whenever anything is combusted, not only biomass, if you are combusting anything, then CO2 and water and heat is produced as a thumb rule. So whenever we are combusting biomass, we are also getting CO2, water vapors, and heat. And
It means
uh,
carbon moves away in the form of CO2.
yeah, carbon moves away in the form of CO2.
Yes.
And the plant body is having minerals also. So
Yes.
minerals are in the form of, say, K2O, that is a potassium oxide, or you have phosphorus oxides, you have nitrogen oxides. You have, if you say, different metals, copper, you have aluminum, you have calcium, and then chromium, and some percentage of zinc, some
Phosphorus,
percentage
potassium.
phosphorus, potassium. So all these minerals that are present in the plant body, they, when the combustion takes place, then their oxides are formed, and that white color is left behind. That is, ash is left behind. It is nothing but the oxides of minerals.
Yeah.
So, whereas if we see for the pyrolysis part, we are not supplying oxygen. So, it is just heating to a high temperature. When a biomass is heated to a high temperature, then the plant body is not combusted, it is decomposed. And the plant body is decomposed into the constituents. Now, the constituents that were initially long chains, if you recollect what is hemicellulose, it is a polymeric material. If you recollect what is cellulose, it is again a polymeric material. If you recollect what is lignin, it is again a polymeric material. When we are heating, then these polymers are breaking down into monomers, and the different fragments are formed. And these different fragments of different chain lengths, we are getting in the form of oil, we are getting in the form of condensable fraction. And we are also getting one product that is called as biochar, that is rich in carbon. When these volatile metals, they come out of the plant body, we are trapping these volatiles somewhere. then whatever is left behind, it is carbon. As you initially said, it is 80% carbon, it is 85 to 90% carbon, then that we call it as biochar. Now the biomass, the volatiles are coming out. What is left behind is carbon is left behind, and where this mineral is going, that was initially in the plant body. It is not gone anywhere. It is present in this biochar in the solid form. So in pyrolysis, we should not get any ash. The ash or the mineral matter is the right word. The mineral matter is present along with the biochar itself. So if the mineral matter in the plant body is say 5% in the biomass, then this 5% will increase in the biochar. So, because the entire mineral matter that was in the 100% of the biomass is now present in this biochar, that is just 30% or 35% of the entire biomass. So now this ash is concentrated, or this mineral matter is concentrated in the biochar.
Yeah, that's good to understand because ultimately biochar has value and along with that ash has some value. So even in the process of pyrolysis, some biochar is converted into ash. It exists with the biochar. Let us say the bark material when we convert into biochar, the percentage of ash is very high in it and that benefits soil in a way. It is not negative, especially in acidic soils. But otherwise, here the purpose is carbon sequestration and ultimately producing biochar, which has its own characteristics in the soil. Say even 1 gram of biochar has about 1000 square meters area. It's very high. So
Right,
another component of analysis is this especially carbon, hydrogen, oxygen, nitrogen, and all these elements and the ratios actually for regarding the stability of biochar in the soils. Especially we have so many protocols to establish that whether this is going to be stable in the soil for longer period or less period. So, say 1,000 years, it can stay. That is one of the things said. But
right,
it varies from 100 years to 1,000 years also.
right,
So, traditionally, you said decomposition. Actually, this is a very important and interesting thing here. Any organic matter also decomposes. And
right.
pyrolysis also, we are saying decomposes. So, here ultimately, in both things, the microbial activity generates heat. That is
Right,
one thing in the process. But here the thermo chemical reaction in biochar is not from microbial activity, the heat generated. So both are a little bit slightly different things here. So, but ultimately, the biomass that existed need to ultimately decompose either in the form of biological or in the form of this pyrolysis
right,
or burning, ultimate burning.
right,
So that is what happening traditionally also everywhere. I mean to say, otherwise the whole earth would have been different with all the biomass. Somewhere in the cycle of nutrients management, this thing is happening. So
true.
here, tell me about this hydrogen carbon ratio or oxygen carbon ratio and other ratios which tell about the stability.
Yeah. So there are different ways of expressing. The first is a proximate analysis we call as far as characterization of a biochar is concerned. So first of all, the basic thing is proximate analysis, and then it goes to the ultimate analysis. So this is one way of characterizing biochar. So in this, the proximate analysis consists of four tests. The first test is the moisture content in the biochar. What is the moisture content that is present in the biochar? Second is the volatile matter is tested. Third is the ash content. How much ash is there in the biochar that has come from the biomass? And the fourth is the fixed carbon. like what is the fixed carbon percentage in the biochar. These all four tests in combine to form a proximate analysis. By and large, moisture content is done in an oven, volatile matter is done in a furnace, and ash is also done in the furnace. Now these three add up, and it is subtracted from 100 to find the fixed carbon content. We cannot determine fixed carbon directly. So these all four things together make the proximate analysis. Now the second test is the ultimate analysis. This ultimate analysis consists of the measurement of carbon in the biochar, the amount of hydrogen that is present, nitrogen, and sulfur. These all four, when added together and subtracted from 100, will give you the content of oxygen in the biochar. So,
Okay.
ultimate analysis consists of carbon, hydrogen, nitrogen, and sulfur measurement, and definitely oxygen after subtracting from the total. So, these all five elements constitute the ultimate analysis. Now comes another way of classifying, in which International Biochar Initiative (IBI) has given the categorization, in which they have categorized these basic tests in category A. So category A consists of physical and chemical characterizations. Physical again consists of particle size measurement and moisture measurement. Whereas chemical analysis consists of elemental analysis, carbon, nitrogen, and hydrogen, and oxygen. So if we talk of carbon, then organic carbon is there. And this ratio of hydrogen to organic carbon, as you were talking about the stability, so this stability of the biochar in the soil depends on the factor of H by C organic ratio. That is, H is the hydrogen to organic carbon ratio. If this hydrogen to organic carbon ratio should not be more than 0.7. We should say that maximum it should be 0.7, then we call it as a stabilized carbon in the soil. If it is zero 0.2, then it is beyond decomposition. If H by C organic ratio is less than or is equal to 0.2, then we call it as it will exist for thousands of years in the soil. So this H by C ratio is very important. If this H by C ratio is greater than or equal to 60%, means H by C ratio is greater than 60%, then we call it as a category class 1 biochar. If it is less than 60 and more than 30%, we classify it as class B biochar, and class C biochar we call it as if it is between 10% to 30%.
It means it is very interesting to note that all biochars are useful, only the classifications are there. The purposes could be different. Is it
Yeah,
so?
perfectly
Because
fine.
the high-end biochar, it has its own purpose and utility factor.
True,
Even low-end biochars also have some other values.
true. And
Yeah.
also, depending on the, I just mistakenly said class A, class B, class C. It is class 1, class 2, class 3. Class 1 if it is greater than 60%, class 2 if it is 60 to 30%, and class 3 if it is 10 to 30%. So if the carbon content is less, then it is still a biochar, but with a different application, as you rightly said. It may not exist in if the if the H to C organic ratio is not zero 0.2. If it is more than 0.2 and less than say 0.7, it is still has stability, and it may not be stable for thousands of years. It may be stable for say 700 years, 800 years.
What
That
does it mean actually? Let me understand in detail. See, hydrocarbons, any biomass, it is made up of. Let us. In
right,
pyrolysis, H should move away. Okay,
right.
it should go out. Let us say if H is already there, then this ratio will be higher. Is it so? If
Uh,
more hydrogen
if
is there, means the pyrolysis did not happen properly.
Can you repeat?
If there is more hydrogen, in the biochar, still it means the pyrolysis did not happen properly.
Yeah, perfectly.
Let us say it is a low temperature pyrolysis that happened, say less than 350 degrees, something like less than 300. So somewhere the more hydrogen is still left.
Right,
It
because
appears dark color, but in fact it is not that long-term carbon sequestration biochar.
right, because in the biochar formation, the reactions that take place includes dehydrogenation also, decarboxylation also, decarbonization also, carbylation also. So all these reactions in which water is also removed, hydrogen is also removed, in which decarboxylation is taking place, CO2 is also getting moved out. So in all these reactions, unsaturations are formed, that is double bond, triple bond, that is aromatic rings are being formed. So more the number of aromatic rings, more unsaturated the compound will be, means less number of hydrogen will be, the more the stability of the biochar will be there.
Okay.
Yeah.
So similarly, this
At
oxygen and
higher
carbon ratio
temperatures,
is another factor, I think.
pardon?
O by C is another
Yeah.
ratio.
O by C is another ratio, and in O by C, I need to check once. मेरे को एक बार check करना पड़ेगा. बस.
Again, I think it is the same issue.
It is the same issue, but it is bit different. It has some other significance also. O by C.
That is increased thermal stability
I need
and
to
resistance
check.
to degradation.
Resistance to degradation is H by C.
A lower O by C ratio.
Okay.
And microbial decomposition also resistance will be there.
I have to check this part. We can include this on a later in our next video.
Yeah.
We can start from there. Because it has two significance, I am not recollecting.
Yeah. Okay, I think this ultimately the surface area is one important aspect in biochar. So this iodine test in biochar, can you elaborate on that? Because this gives the significance of the total the space that is available within the biochar. So that whatever the characteristics that we have for biochar, those things are enhanced.
So, Dr. Sai, before moving to iodine number and surface area, I would like to complete this category A classification as per IBI, in which
Okay.
in which the basic characteristics of a biochar includes the chemical characterization, in which I just discussed about this elemental analysis. Apart from this, there is other parameters also that need to be tested. That is, pH is need to be tested. That is, electrical conductivity of the sample needs to be tested. So these elemental analysis, organic carbon, pH, along with
Catalytic capacity.
electrical conductivity, along with particle size as a physical parameter, and along with this moisture as a physical parameter, makes category A as the basic parameters that need to be tested for any biochar to be called as a biochar. So we should test our samples for all these parameters. I will again repeat, that includes particle size, moisture, all the elements, 5 elements, organic carbon, H by C ratio, O by C ratio, along with EC and pH. Now moving to our second category.
Here I think let us understand if there is more electrical conductivity in biochar, let us say it means biochar has some free electrons. Is it so? Because
Definitely, yes. Means they have free electrons, and that complete aromatization or the that has not taken place, and it is more conducting. So more of the salts can be moved towards the plant if it is mixed with the soil. So any biochar that has high electrical conductivity is good for soil application. And you are the expert in this, so if I am wrong, then please correct me for the same.
Another plus or minus factor is the pH. Most of the biochars at the end, they are slightly alkaline, and it
Yeah,
can go up to 9, 10 also some biochars.
right.
So this had been a challenge for some people when they want to apply biochar in the alkaline soils.
True.
Uh, yeah, this factor is there. Yeah, why usually the pH is high on the higher side for biochars?
Yeah, because in the pyrolysis, all the volatile fractions are getting eliminated, and it is oxygen-free environment. Uh, Secondly, and thirdly, if you see, आप बताओ, I'm not recollecting. What
Yeah,
can it
yeah, it's
be?
okay. So here I think there are some other things like cation exchange capacity. That
Mhm.
it has very high cation exchange capacity, we say, especially the nutrient solubility that the biochar makes for the plants. So
Mhm.
this particular characteristic is one of the important things for biochars.
Yeah, definitely. If electrical conductivity is a very important part that will help us in deciding the cation and ion exchange ability of the biochar when applied to the soil.
So another factor like heavy metal contamination and other things people say this is an important aspect in biochars. So where
Right.
do they get retained in the plant matter? How do they get deposited within the plant matter so that when we do pyrolysis, still these heavy metal contaminants are there?
Yeah, so whenever it depends upon the feed stock and upon the soil condition they are growing in. So whenever a plant is growing in any contaminated soil, contaminated means whether it is irrigated by a contaminant water or the groundwater is contaminated, then the plant has a capacity to absorb those minerals. So they get concentrated in the plant body in the form of contaminants or toxicants in the plant body itself. Now, when we are doing pyrolysis, then it is not necessary that all of them break down because pyrolysis or the biochar is getting formed at different levels. Now, we are either doing pyrolysis at 250, 300, 350, or say up to 800, 700, whatever it is. So entire range of products are available with us with different temperatures. So it is not necessary that these organic compounds they have the same degradation temperature, and they degrade into all the poly aromatic hydrocarbons. PAHs are there, polycyclic compounds are there. So they all add up to toxicants in the plant body. Furans are there, and so it is not necessary that they all are removed during pyrolysis. So we need to test these parameters as a mandatory test again for qualifying your product as a biochar, and before applying it to the soil again, so that the healthy soils after application of these biochars should not turn into again into a polluted soils or because of the toxicants in the biochar.
Another aspect is like NPK is very, very important in the soils. So because NPK is also part of the plant biomass. So
Right.
after pyrolysis also some NPK is going to be retained within these biochars, or is it available to the plants? What is
Uh,
the relationship with this kind of nutrients existing?
Yeah, so these NPKs is still retained into the biochar, and they are either available as directly or to the plant body, or they have to be in the soluble form by mixing it or by charging them with some cultures or some solutions that can convert these unavailable forms of NPK into available forms. So yes, but it is available in the plant biochar itself, and that also depend upon the feed stock. For example, if we talk about Pongamia pinnata, so this karanja variety is already having lot of potassium in it. So when such a variety is used to produce biochar, then its potassium content is by and large very high in comparison to other varieties when we are making biochar out of it. So it is feedstock specific. Secondly, these are available into the biochar. Thirdly, they may be taken up directly by the plant, or some microbial culture has to be added to this biochar to activate this biochar so that this unusable minerals can be converted into a usable form.
Okay, like charging and inoculation are the two ways that we enrich the biochars. So that
Right,
way they host these nutrients
right.
which benefit the plants. So most important is this microbial communities. Again, this testing is completely different because microbes they are infinite. We can't even count the types of the numbers are huge, and the types are also many. And
Yeah.
in every geography they vary a lot. So, but ultimately, this is one important aspect when we want to apply biochars to the soil. So, how can we assess the characteristics of each biochar as a host to for a set of important microbes? Yeah, even fungi and all that. So, this is one important thing.
Yeah,
Yeah.
so this is very important, and I may take another session on this. But as a basic information, I can provide you, like IBI has again, as I told you initially, that IBI has categories for testing, characterization of biochar. So the first category was category A, in which the basic biochar characterizations properties has been defined, which we just discussed,
Mm.
like this moisture and particle size, and this elemental and EC,
Yeah.
and this part. Second, category B is there and category C is there. As your question right now is on microbes part, so category C I will discuss. Category C includes advanced analysis and soil enhancement properties. So this category includes parameters like mineral available nitrogen, ammonium, and nitrate. So this test is specifically for testing about the ammonium content, about the nitrates, and the ammonia and the nitrate in the biochar, how much it is available. Total phosphorus and potassium, how much it is available. Similarly, total calcium, magnesium, and sulfur tests are there. And again, in this category only, we have total surface area, as you were discussing initially about the total surface area. So this total surface area measurement is in this category C, that is not mandatory to test or to qualify a biochar as a biochar. So category A is mandatory. All the tests present in the category A are mandatory to be taken for a product to be called as a biochar. But if we are going for soil application, then only we will go for this category C, in which you have all mineral testing, that has nitrogen in the form of ammonium and nitrate, that has phosphorus, that has potassium, that has calcium, that is sulfur. And along with it, that has surface area also, because surface area is measured in meter square per gram. As you have mentioned just before the start of this session, like the surface area is 1,000 meter square per gram. That is very true. Even some biochar have higher than this, and some have lower surface area than this. And this surface area is present in the form of different pore sizes. It can be micropores, it can be mesopores, it can be macropores. So more the micropores, more the surface area. So, as you were talking about iodine number, so iodine number is a test that is used to find out the micropores in the surface area. Iodine is a small molecule. A micropore is a small area where these particles they enter inside and they reside there. If a pore size is bigger, then iodine is such a small molecule that it will go inside and will come out. It will not be residing there in the pore. So if any carbon material is having a high surface area and having a high iodine number, so that means that particular biochar is rich in micropores. High iodine number signifies the presence of micropores in the surface.
It means it is adsorbed onto the biochar when
Onto the
treated.
biochar, and it is measured as milligram per gram of carbon, milligram of iodine per gram of carbon. If we want to find out the mesopores, then the test is of methylene blue. Methylene blue is a dye that indicates the presence of larger pores in the biochar.
Okay. So between this adsorption and absorption, there are two things actually.
Right.
Adsorption is like iodine, we said, it is adsorption, ADSORPTAON.
Right.
Absorption is getting deeper into it.
It is a bulk phenomena, whereas
Yeah.
absorption is a surface phenomena.
So what are the things which are absorbed by biochar? So because that is also important, no, altogether, because people will say adsorption is, let us say, it is at the superficial level. It can easily dislodge it again, something like that. But absorption is it goes into biochar.
So that is soaking, I feel. We need to soak it for long for it to absorb. For adsorption, it is a surface phenomena, and the time is also a great factor in absorption and adsorption. If we are doing it for few minutes or few hours, then it will take time because the movement of the solute takes place by capillary action. On the surface of the biochar, there are very thin capillaries that are present, because if you are seeing the size of the micropore, it is just 2 nanometer. That is 2 into 10 to the power minus 9 meter. That is such a small pore, and they are interlinked inside the surface of the biochar. So in that form, if you see, then capillary action takes place and the absorption will take place very slowly. So the time is also the essence. If we will leave biochar soaked in a particular solution, if we are calling it as charging of the biochar with some nutrient or microbial solution or inoculum, then you will find that we are soaking it overnight or for 48 hours or for 72 hours, so that it will go deep inside into the biochar. Whereas for these testings, be it iodine number or be it any other test, we are doing it for less than a minute. We are just keeping it for a minute so that it is absorbed on the surface, and or 2 minutes maximum, depending on the protocol. So it is not a bulk phenomena. For bulk, time is the essence.
So we can say this absorption is charging.
Yeah, we can say.
Adsorption is inoculation, something like that.
Yes, we can say as a common sense, we can
but
say
not
that.
exactly in the sense at that micro level. Yeah.
Yeah, we
And
can
most
check.
important, another factor is this polycyclic aromatic hydrocarbons or polychlorinated dibenzo P dioxins, like that. So these are something called harmful in biochars. So you can say something about this.
Yeah, so this falls in category B. Toxicants of the IBI again has, I will again repeat, they have categorized characterization of biochar into three, category A, category B, category C. We have talked about category A and category C. Now this is the category B, that is for the testing of the toxicants in the biochar. So these toxicology tests have to be performed on every biochar, or should be performed if we are going to apply for the soil. remediation. So, for example, if we are going for a cement industry or a construction industry where we are mixing it into a cement and we are applying into the road, so there is no use there. It is not required to test for the toxicant. Whereas if we are using this biochar for the living organisms, then definitely we need to test, and it falls under category B, where polyaromatic hydrocarbons, where dioxins and polychlorinated carbons, these all tests are done along with metal ion contamination. Because say for example chromium is there, then it should be within the range. Arsenic is there, mercury is there. These heavy metals should not exceed a particular limit, because this, when applied to the soil, will be absorbed by the plant body. That plant body will again be consumed either by the animals or by human beings, by the living organisms. They will accumulate in the living organisms once consumed. So these biochars should be a source of growth, should be source of CO2 sequestration, but should not be a source of contamination, or should not be a carrier of toxicants.
Yeah, ultimately, see the scanning electron microscope. Sometimes the challenge here is when a poor farmer is applying biochar, people would say that this is not biochar, that is not biochar. Did you test even one sample for all these kind of tests? It will be more than 1 lakh rupees, I'm sure. Right from microbial to all elemental, say X-ray diffraction method or the scanning
True.
electron microscope. So even proximate analysis, ultimate analysis. See, where is the need for a farmer who is not into carbon credits or carbon sequestration and all that? And for him in his life, he might be looking about 30 years of his agriculture time period as a livelihood, or maybe 40, 50 years at the most. So I think most of these standards and testings are very, very important in the context of this global carbon credit market, and already there are governments insisting, and biochar is definitely one of the best solutions, not only to address our most important fundamental challenges of reclaiming lands to improving fertility overall in its presence. To water treatment or environmental, all kinds of pollutions it can take in emission reductions. So there is so much value when we are looking at such deep values, and then at a higher level, if somebody is coordinating and supporting the farmers with some incentives, then definitely yes, they have to undergo all these procedures. Otherwise, most of them are doing traditionally their own way. So that's why I always said one thing. See, there could be n number of standards. Even now we have European certification standards, IBS standards. So many new standards are also coming into picture. That's fine. That is coming from the developed countries. So mostly. But whereas in the poor countries or developing countries, still we have many challenges at the ground level, and any cost that incurs in this kind of standards will keep the farmers away from adopting. So this is what my understanding. Second thing is in biochar in all its forms, because we said different categories of biochar from different feedstocks or different temperatures. Everything has its own value. 100% it may not have the value of the high carbon content biochar, but every biochar has some value. So
True.
I think we need to look differently, especially in this giving some flexibility to the poor farmers and to be part of this movement. I call this biochar revolution, and we need to work out, especially for the Indian standards also. With that, the government already going through this green credits and carbon credits for India alone. When we go for international carbon credit, definitely we follow their rules. I'm not against the standards or anything, but I'm only telling the possibilities of inclusive, rather telling that you don't know, you don't know, you don't know. Even like a scientist, sometimes we argue a lot. Do you know this? Do you know that? Whatever you are applying, do you know how much damage it can cause? Something like that we discuss a lot. But I think this kind of flexibility we should give, And today, I think you brought up so much knowledge and the details that comes only from very intense research and understanding. A person like you has dedicated your life in this sector, and I am happy that you brought up this details. And at least this is not at the farmer level. Definitely, this is already at the level of people who are already researching online and getting confused. Also, they
Yeah.
need some clarity. And any educated youth, they can understand better this conversation. And we need only intermediate science, something like that in all this.
True.
Beyond that, we can learn more. Yeah, thank you very much, Dr. Sonal Garg, and we'll continue our these discussions for the benefit of the communities working in various sectors related to biochar.
Thank you so much, Dr. Sai, for giving me this opportunity, and we'll definitely continue these sessions so as to bring more insight into this biochar field. And I'm very hopeful that government is also like moving with the credit part the government has given. So characterization also, some basic characterization which we talked is definitely required at the initial level, and labs should be available where these testings can be done. These at present right now we don't have much labs, because of which the cost is very high. So once government will have in their vision on this particular product, then I am very sure that soon the cost will also decrease in government institutions, because these are basic tests. Only one oven and one furnace is required for proximate analysis, and yes, for ultimate you need to have a expensive instrument that is known as CHN analyzer. So apart from that, pH meter is also not very expensive, and electrical conductivity meter is also not very expensive. So we should, through our this discussions, and we should bring to the notice of the government also that what is the need of the hour and how it can be addressed. Thank you so much.
Yeah, good. Thank you very much.
Thank you.